This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So, in this particular topic in our data structure and algorithm series, time complexity I'm going to cover because it's one of the most important interview questions that people will be asking you. That one will be how will you calculate the time complexity of a particular of a particular algorithm that you have written, whatever the code that you have written, and then you have to calculate, you have to show them, okay, why this is the time complexity O1 or ON or ON square, and multiple time complexities are there. But before that, we have to understand what do you mean by time complexity. So you must be hearing about the big O of N. So time complexity, guys, it's very simple. I'm not going to give you some big names over there, but simple language, the time complexity is the estimation to check how exactly your algorithm is going to perform. Doesn't matter on which machine you are running on. Okay, it doesn't matter on which programming language you are using it. Time complexity is nothing related to Java or Python or C Sharp. It's a common term to be used for calculating that how much time your algorithm or how much time your program that you have written will take time. Right, that's very important. Right, so how many iteration it will perform, how many times that particular piece of code or piece of line that you have written, how many times it will, okay, it will be repeated, and how many times it will be executed when you execute that particular program. So then, so time complexity, guys, generally what we do that, okay, there is a notation is already defined that is called big O. This big O. This is called, okay, this is called a method to define, or this is called a symbol to define a time complexity. So what we say that, okay, time complexity can be defined in the form of like this. Let's see, big O of n, big O of 1, like this. So I'll tell you what do you mean by this. Big O of, let's see, On square, like this. So this is, let's see, On square, like this. Okay, On cube, log n, logarithmic, and everything we can define. So today we will talk about O of 1, n, and n square. And in the next chapter, I'll tell you what do you mean by other complex time complexity formulas also. Right? So this time complexity defined as a function. So this O of n square and O of n, if I say that, okay, it's a kind of a function over here, let's see, function of fn over here, which is equal to On or On square or whatever, like this, right? So this formula is saying that, okay, yes, n means number of items, number of elements that you are passing, and number of iterations that you are performing for that particular algorithm or for that particular code that you have written. It means n is the input size for your algorithm or for your program. And big O notation means the formula, the time complexity notation. Okay. So n indicates the size. Remember this thing. So n means the size of the input that you are passing. Okay. And O is, I would say, notation for time complexity. I say TC. So remember this thing. It doesn't matter that how exactly you are saying, but at a time of interview, when you're giving the interviews and everything, make sure that, okay, you're using the right term for that. Now, how to calculate, that's something important. So today we will see O1, ON, ON square. Then other than that, we have in the next chapter, we will be covering about what we mean by O of n log n. That also something important. There's a typo, log n. Okay, that also we will see that. Now, what do you mean by, let's see, O of, then we will talk about n factorial. That also you can do that. Then we will talk about the big O of 2 to the power n. That also we can see that. So these are the complex one that we will do it in the next chapter. But today we will talk about the first one, the O1, ON, and ON square. And along with that, we will be doing that ON cube also. We can do that. Okay, along with that. Now, what we have to do, guys, in this particular Let's write some code, and then you will you will relate that okay how exactly we can calculate the time complexity. So this is the src and big O I have written, one package I've created. So I'll be writing a code in Java, and then you will see how exactly it's running. So let's say I'm going to create a class, and my class name is, let's see, time, or I say that okay, time complexity big O, whatever the name you want to give. Select the main method and click on finish. When you write the main method, click on finish. Let's see the first, I'm writing a variable over here, a constant variable, or what if the variable, like not the constant, let's see, and n is equal to 1. And if I run this particular program, I'm printing system.out.println n. If you run it, it's simply printing 1. Okay, it's simple printing 1. It means the time complexity for this guy, it will be executed how many times? It will be executed only once. So the big O of 1 will be the time complexity for this. Okay, big O of 1, the time complexity for this, right? Now, let's see some more examples of O of 1. I'll write a code over here. Let's see, integer number is equal to 20. I want to calculate that, okay, this number is odd number or even number. So how we do that? The very simplest thing that, okay, you will be writing number models to equal to 0. Then you want to write system.out.println what? This number is the even number. Else you simply write system.out.println, sorry, system.out.println, and then I simply write odd numbers. Now you run it. You see that okay, it's printing even, and if you write, let's see, 21, which is the odd number, it's saying odd number. So how many times this guy will be executed? Number equal to 21 will be executed only once, right? Will be executed only once. And this entire thing also, it will be executed on the basis of your number equal to 21. Now this code you write, you execute 1 times, 10 times, or 1,000 times, that doesn't matter, because it will be executed only once. This guy also will be executed only once. Doesn't matter what kind of number you are passing over there. If your number is 100 or 10,000 or 1 lakh, that doesn't matter. Number modulus to equal to 0, it will perform this particular either this or else. But this entire code will be executed only once. So that's why I can say that okay, this is the big O of 1. Once again, right? Odd and even number. So let's see. This is my odd and even number. Complexity will be O of 1 always, right? And this is what? A simple variable, a primitive data type I have declared, or it could be any string, or it could be any double value or character or whatever. You declare any primitive or non-primitive data type, or whatever the variable that you are defining, and you're just printing it on the console or using them, that doesn't matter, right? So this is the O of 1. Now let's talk about big O of n. How to do that? Okay, the big O of n. For doing this, let's see. Um, I have to write a for loop. Simple task can be okay, simple, very simple program. I'll be writing 1 to 10. I want to print it on the console. So how will I do that? I'll declare a variable, or let's say I'll declare a for loop simple. I simply write start int I equal to 1 and I less than what? Less than equal to 10, and then I plus plus. And then I simply write system.out.println the value of I, and then you run it. You will see that okay, 1 to 10 is getting printed. Now I have to calculate the time complexity for this guy. So how will you calculate? So we will go through each and every line. I equal to 1, it will be executed once. So let's see, 1. Then I less than equal to 10, it will be executed how many times? 10 times, right guys? So 10 is the number. So let's see, I'll declare something like this, n, okay, n1 is equal to 10. And I simply say that, okay, this is I less than n1, right? So whatever the number that you are passing, the value that you are passing, 10 times it will be executed. It means this particular condition will be executed 10 times. So can I say that n times 10, 20, 30, 40, tomorrow you're writing 100, so it will be executed 100 times. So I have to generalize a term. I simply say that, okay, 1 plus n, it means this particular condition will be executed n number of times. It depends, n means the number that you are passing over here. Same thing, I plus plus will be executed n number times until the condition is satisfied. Because every time the condition is satisfied, and then it will increase the value. Then system.out.println also will be executed n number of times. So what is the formula that we are getting? We are getting 1 plus what? 3n. 1 plus 3n, right? So 1 plus 3n that you are getting. Now assume that, okay, you are printing 1 to 100 or 1 to 100, or let's say you're printing 1 to 1000, or you are printing 1 to 10,000 or 1 lakh or whatever. How does it matter? It means the number of iteration you are just increasing. It means if you're writing 10, getting executed 10 times. If you're writing 1000, it getting executed with 1000 times. Same thing with other guys also. So the formula will remain same always, right? 1 plus 3n, right? So what is the significance of this one? What is the value I equal to 1 that you have declared over here? What is the significance? If you're executing 100 times, I equal to 1 will be executed only once. Same thing for 1000 or 10,000 or 1 lakh also, or millions of times. If you're executing this particular code, this I equal to 1 will be executed only once. So as compared to 10,000 or as compared to 100 iteration, I equal to 1 is negligible. So that's why this is a constant we will ignore, right? So if you ignore the constants from here, what is constant here? 1. I simple getting 3n, right? I'm simple getting 3n over here. Then when you get the 3n over here, then what? If you're getting 3n, in that case, 3 iteration you are doing for this, right? Doesn't matter what kind of number that you are doing. So 3 iteration means iteration only for loop only once, but 3 things you are getting executed. And this is n, n plus n, n plus n. And if you ignore from this particular 3n, if you ignore the 3 also, this 3 is also a constant over here, the multiplication factor over there. That doesn't matter that n equal to 100 or 1000 or 10,000, 3 will always be there. So if I ignore 3, in that case, what exactly I'm getting? N. So that's why the time complexity, I can say that, okay, this is a big O of n over here for a single for loop, big O of n, right? So this is also, we can do that like this. So you have to explain the formula like this, and you have to calculate, and finally you have to keep ignoring all the constants, 1 and then 3 and everything, and then finally you are getting what? O of n. But here this is O of 1 because these guys are getting executed only once. They are not in the for loop. So not n number of times will be executed. So n equal to 10, it means On like this. Okay. Now let's take one more example for O of n. So example is you have to write a program, a very simple program. Let's see, write a program to find out or to find the largest element or largest number on an unsorted array. Okay, there is an unsorted array is available, and you have to find out the largest number over there. How will you find out, right? So let's see. I'm going to create an array over here. Let's see, integer array is equal to, this is unsorted. So I'm simple writing, let's see, 2, then 20, 34, then 56, then 5, then 43, then 2, then 3, then again 67, then 89, and then 100. And then I'm writing 45. So this is totally unsorted, right, guys? Let's see like this. This is totally unsorted. It's not in the sorting number. Randomly, I have written some numbers over there. What I have to do, I have to find out the largest element. What is the largest element here? Largest element is 100. So I have to find out that. So I simply do one thing. I'm gonna do that. Create a max number over here with equal to 0 initially. Then I start a for loop, right? A for int I equal to 0, and then I less than what? Whatever the array dot length is there, and then I plus plus. And I simply do one thing, that if your max number is less than array of I, then what? Get your max is equal to array of I, and then you have to keep doing it, and then you come out to the for loop, and then you simple write system.out.println, print the value of max number. right? So this is my array, max equal to 0, I equal to 0 less than this. Max is initially what, 0, 0 less than what, array of I is equal to 2. If 0 is less than 2, you get the max. And you just keep doing that. It means first time initially was 0, then I initialize with, okay, max now 2. Now the every time it will be compared, and then when we get that 100 over here, finally we get the 100. Next time 45, 100 is less than 45, no, it will come out of this, and then we will get max over there. So let's run it. Let's see what exactly we are getting. We are getting 100. See, this is the max number we are getting. Now let's remove this 100. Now what is the max number? Max number is 89, so we should get 89. See, 89. If I say that, okay, hey, 450, so we are getting 450 now. So we are getting a max number. So a very simple formula, I mean simple code I have written over here. Now the thing is, how will you calculate what is the time complexity for this? So if I say that, okay, for max equal to 0, it will be executed only once. So this is 1. And this entire loop will be executed. It depends what are the different elements that you have written. So let's say if you have 10 elements or 5 elements, or it doesn't matter what exactly the length of the array. So let's say length of the array will be executed means n number of times, right? Length of the array will be executed means n number of times over there. Okay, then n number of times, and then I'm printing this guy also will be executed only once. So the final formula for this entire code from here to here, what will you write? 1 plus n number of times plus 1. Can I say that? So this will be equal to what? 2 plus n. And if I ignore this particular 2, the constant, right? Because that 2 doesn't matter. If you have 1,000 data or 1 billion data, also 1 million data in this particular array, doesn't matter, max equal to 0 and system.out.println will be executed only once. So out of 10,000, this 2 doesn't matter. 2 doesn't have any significance for time complexity point of view, right guys? So then in that case, if I ignore the constant, I'm getting n. So n is what? The big O of notation is big O of n. So the time complexity for this guy, it will be big O of n. Simple, right? Now let's see one more example for O of 1 once again. Back to O of 1. So O of 1 is not only for variables. You can define, let's see, odd even number, a simple algorithm. Now let's see, I want to create a hash map and fetch the value from the map. Or let's see some lookup table, something like this. I want to create that. How to write a code? Simple. So let's see, I'm going to create a hash map over here. That, okay, let's see a table over here, or hash map table, a lookup hash map instead of this. And then I'm creating a hash map that, okay, hey, this particular map will be holding some string, or let's see, integer, comma string, and I'm writing student marks is equal to new hash map, again integer, comma string. I'll be writing over there, and you import these two values from java.util package. Now I'll start putting the data over here. Dot put, and the first key is 1, and the data is, okay, let's see, the first is print, the data is 100. Or let's say the student is okay, okay, whatever. Let's see the student marks. So I'll say that, okay, this is a string and the student marks is what, integer. Okay, I'll just write the generics like this. So this is string and integer. Okay, like this. So for the student name Tom, marks he got in integer, let's see, around 100, like this. And then I quickly write two more students, Tom, Peter, and Steve. They got 200 and this guy got 300. And then if I simple write system.out.println that student marks dot get and pass the key. The key is like, let's see, hey, what is the score for Peter? So what is the score for Peter? The score for Peter is 200. So I'll be getting 200 over here. See, I'll be getting 200. It means if I say that, okay, hey, what is the time complexity for this lookup hash map or for this particular student marks map? It means you are just adding the value. It will be executed only once. So 1 plus 1 plus 1, let's see 4. And then for this guy also, this is only once, right guys? So it doesn't matter that, okay, what kind of data that we are passing. We are not passing any kind of data. This is not an array or something. This is simple math we have written over there. So what is will be the time complexity for this guy? So time complexity for this will be what? Will be O of 1 always. Okay, will be O of 1. So this is again the big O of 1. It will be executed only once. That's it. Okay, O of 1, right? So now this will be O of n. So if I say that, okay, if I write a formula over here, right, a linear equation. So if I say that, okay, this is a linear equation, what will be the linear equation for this guy? For linear equation, if I say that, okay, this will be simple, okay, n plus 1. This is also a linear equation, or you can simply write 2n plus 1. This is also a linear equation, or you can simply say that, okay, 3n plus 1. This is also a linear equation, or you can simply say that, okay, only n number of times. This is also a linear equation over there, right? So this is what simple. Now, if I ask you that, okay, this largest item on the sorted array, how many times is getting executed? O of n. It depends what kind of data that you are passing over here, right? What kind of data that you are passing. Now, this is the largest number that you are writing over here. If I create a graph, right, guys? If I create a graph, so let me create a graph over here for you. Let's say this is my x axis and this is my y axis. And then if I say that, okay, for O of n, what, let's see, if you are passing only 3 elements, so how many times it will be executed? 3 times. So let's see, this is 1, this is 2, this is 3, this is 4, and let's see, this is 9, and this is 10, right? And this is 1, this is 2, and this is 3. Assume that. And again, same over here, that, okay, the size will be like this. This is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, and 9, and 10, somewhere like this. And this is 0, 0 coordinate. If I say that, okay, 3 elements and 3 times will be executed, so can I say that this is 1, this is 2, and this is 3, and let's see, this is 9. So this is somewhere pointing over here, right? This is what? 3 and 3. So if I draw a linear equation like this is what? 3 and 3, 3 and 3 coordinate. Same thing, let's see, number of elements are 9. So 9 elements, 9 times this for loop will be executed. So 9 will be somewhere over here. Okay, it will come over here, somewhere over here, right? So if I say that, okay, this will be a linear equation like this, somewhere it will point over here. This is 9 comma 9 over here. So what exactly the outcome is coming? If you see the graph, if you have more data, let's say tomorrow you have hundreds of numbers available over here. For hundreds of numbers, the complexity will be like this. Somewhere it will point over here. So this is 100. So it will create a linear equation. You can see that. Okay, sorry for the graph, guys. So it will be like this. It will be a linear equation like this. It means the moment you increase a number, the time will be increased. If you have only one number, this will be the time. If you have more number, 5 numbers, this will be the time. If you have 100 numbers, this will be the time. If you have 10,000 numbers, the time will be more and more in that case. So it will create a linear equation like this. The more data you have, the more time it will take, right? So remember this thing, this will create a linear equation like that. Now let's talk about O(n) square. Okay, so I hope this is clear. O of 1. O(n) square. O(n) square is always used for when you have, there are a lot of algorithms are available. This is called quadratic equation. So it will create an equation like this, simple mathematics. It will create an equation like this, 2n square or let's see n square, n to the power 2 plus n plus 1, or it might create something like this, 2n square plus 2n plus 3. So it will create a quadratic equation. So for quadratic equation, how do you solve this problem, right? So let's see, I have a simple one thing. I want to print a series like this. Okay, let's see, 0 0 0 1 0 2 0 3. Then I want to print something like this, 1 0 1 1 1 2 1 3. Then I want to print it like this, 2 0 2 0 2 1 2 2 and 2 3. This is the kind of matrix I want to print, or a kind of series I want to print in this particular format. So how will do that? So I'll prepare first my for loop. I simply say that, okay, hey, int I equal to, or let's say int m is equal to 0, and m is less than what? M is less than equal to 3. Let's see. And m, keep increasing the value, and put one more for loop inside that, int n equal to 0, and n less than equal to 3, and then n plus plus, like this. Okay, I think the n we have already taken, so I'll write, let's see, p plus plus, whatever the variable you want to write, and then you will write simple system.out.println. You will concatenate m plus p like this, and then you put a space over here, let's see, like this, so that you will get something like this, right? So if you run it, what will you are getting? You are getting 0 0 0 1 0 2 0 3 1 0 1 1 1 2 1 3, like this. Or let's see, if you really want to print in the same line, you simply write it like this, then it will be printing in the horizontal line. But after 0 1 2 0 3, I want to print this series in the next line. So how will you do that? After that, I simply come out of the inner loop, and then system.out.println, I generate a new line over there, and then you run it. Now you are getting the exact series over there, that 02 03 and 302 33. And then if I say that, okay, hey, what will be the time complexity for this guy? So if I calculate the time complexity for this guy, it means this inner loop, how many times will be executed, right, guys? So inner loop will be executed. Let's assume that, okay, first inner loop or outer loop. So this is called outer loop, and this is called inner loop. So first outer loop is getting executed, let's say, m number of times, and it could be 30, it could be 100, it could be 40. So let's say if I'm writing 10 and 10 over here, you run it again, you're getting a series over here like this, right? So it depends what kind of data you are passing, what is the size of your input. So let's say I'm writing once again 3 to 3. So it's getting executed 3 times. So I say that, okay, m times 3 4 5. So I would just want to generalize a term. I say that, okay, m number of times will be executed, and then along with that we have other things also, m equal to 0 and m plus plus. So if I say that, okay, this is 1 plus 2m times will be executed, n plus m. So this is equal to what? 1 plus 2m, because this also will be executed m number of times. Same thing for this guy also. So for single m, it will be executed, same formula. I'll write it over here, that 1 plus 2n times, okay, or 2n time or whatever, yeah, or 2p times, which depends what kind of p that you have written, 3 or 4 or 5 or something like this, right? And then we have these constants that, okay, system.out.println, and will be executed one by one for every time. So if you generalize the formula over here, I simply say that, okay, 1 plus 2m multiply by what? 1 plus 3m, like this. And if you include that, let's see, this particular system.out.println, and this also will be executed in this particular for loop, which is part of, let's see, this 2 or 3 constant also. Now, the formula, what exactly you're getting? 1 plus 3m plus 2m plus 2 multiplied by 3, 6m square, right? 6m to the power 2. Simple mathematics, quadratic equation, right? And then what exactly you're getting? 1 plus 3 plus 2, 5m, and then you are getting what? 6m square, 6m square. If you ignore one constant. So out of this equation, one has no significance over there. So remove this particular one from here. So what exactly you're getting? So can I say that 6m square plus 5m, 6m square 5m. So can I say that this is a quadratic equation just like this, 2n square 2n plus 3 or something like this. Same thing, we are getting 6m square 5m plus 1. A quadratic equation formula we are getting, right guys? So we are getting something like this. So in that case, what exactly we are going to do that? In that case, 6m square plus 5m. So I remove all the constants from here. So I simply say that, okay, m square, m to the power 2 plus what? Plus m. So this m also has almost negligible significance as compared to m square. So if I ignore m also, why? Because let's see, this is getting executed 3 plus 3, 3 and multiply by 3, 9 times. Tomorrow you have, let's see, 100 multiplied by 100, 10,000 times. It means this particular m has no value out of as compared to 10,000. So in that case, if I ignore m from here, so I can say that, okay, this is m of square, whatever, m square, n square, whatever you have taken. So don't be confused. I should have written 1 plus 2m and 1 plus 3p or 1 plus 2p, whatever I have written over here. Okay, the same formula. It's like this, 1 plus 2m multiplied by 1 plus 2p. So you don't be confused like this. It's like 1 plus 2p. Ultimately, if m equal to p, then you are getting something like this. Let's see, 4m square. So these constants actually doesn't matter, guys. And now this will be, let's see, 4m square plus 5m. And then if you ignore, ultimately you ignore 4 and 5 from there, you are getting m square plus m. And against this particular m square, this m has no significance. So finally you are getting m square. So can I say that this is big O of, notation is always n to the power square, O n square. So the time complexity for the two for loops, guys, like this will be O n square. So it will create n multiplied by n. So if you have 3 multiplied by 3, it means this entire logic will take, it will be executed 9 times. Will be executed 9 times over there. You run it again, you can see that's like this. Okay, or it's 0 to 3, not 9 times, sorry, 0 to 3 means 4 times will be executed and 4 times this guy will be executed. So if I say that, okay, this will be executed 4 by 4, it means 16 times, not 9 times, 16 times will be executed. That's why you can see that, okay, this is the first time, then second time, third and fourth, 4 multiplied by 3. Okay, 4 multiplied by 3, 12 times, sorry. Okay, will be getting executed like that. Or see, I'm just giving you a very hypothetical numbers, right? 16 times, 12 times, but it will be always m multiplied by n. How many times your for loop, outer loop or inner loop will be executed. So 16 times, 12 times, 13 times, it will always be a calculation, a square calculation. Okay, so that's why it is represented by on square. So let's don't be confused with 16 times or 12 times or whatever. It will be on square. It will create what? A quadratic equation over there. Okay, so on square is also called a quadratic equation. Remember this. Quadratic time. And that earlier we have seen this is a linear equation. Okay, now if you see the graph for on square, now see on square is a very poor okay, if your algorithm is taking on square of this, then it will be very horrible. So on square will be like this. So we have already seen that the linear equation. So let's see, this is O of 1 out of x and y, and let's see, this is what? O of n. On square will be like this. On square will increase a time like this. Okay guys, like this. So if you have more elements, it will increase the time like anything. Okay, so let's see, this is a time and this is the element graph, x and y axis. So if you have a small element, it's taking, let's see, 1 second for one element. The moment you increase your more element, it will take more time like this. You see the time like anything, it's crazy. So ON square is really performance wise very poor. It will take a lot of time. That's why you can see that okay, two for loops in a loop for every m p will be executed. So n multiply by 3 times over there or 4 times over there. So for every m inner loop will be executed 3 and 4 times. So the moment you increase your outer loop, you have 100 data and 100 multiplied by 100 means 10,000 times. So for 100 elements in your outer loop, 100 by 100 times this entire loop will be executed. So ON square will be very pathetic. So this is ON square loop. This is I would say O of n, and this is I would say O of 1. So which one is better out of these three? O1 and then ON, and then we have ON square like this, right? Now let's see some more examples of ON square. One more example, we will see that. So I would say that let's see. You have to write a program to get the duplicate number from an array. From an integer array, you have to find out the duplicate number, right? So I'll simply create one duplicate array. So let's see duplicate array is equal to, and I write let's see 2 comma and 3 comma 10 1 comma 45 comma let's see 45 once again somewhere 56 and 45 once again, then 3 is once again, then 67, then 65, then again 67, and then 100, right? So some elements are duplicate. You can see that 3 is duplicate, 45 is duplicate, 67 is duplicate. So how will you find out? So I'll maintain a for loop, one outer loop in I equal to, okay, I simple write it like this, and I equal to 0, I less than what? Less than up to the duplicate length. How many? Length of this particular array, and then I plus plus. Then again I'll write a for loop in j equal to 0 and j less than what? Again duplicate dot length, and then j plus plus. See guys, we can solve this problem in a different way. We can use hashmap also. We can use some other data structures and algorithm also we can use. But my purpose is to just give you, if we are solving the problems like this, what will be the time complexity? So my focus is on, okay, not on the solution, the exact proper solution. What is the best solution? I'm not saying that. I'm talking about the time complexity with these kind of equations, with these kind of formulas, okay, with these kind of algorithms or the program that you write. Okay, then I quickly write if I equal to j, then I simply say that okay, you just continue. So I simply write continue. If I equal to j, right? What else? Two duplicate elements are available on the 0th position in that case, or first position. And then I simply say that okay, if your duplicate of I, let's see, yeah, equal to your duplicate of j, it means we have found that element, the duplicate element, and then I simply write that okay, hey, system dot out println, which element? This duplicate of I simply say that okay, plus, sorry, is the duplicate element is duplicate. I simply write it like this, a simple thing. Okay, then let's run it. So we should get all the duplicate elements. So I'll run it. You can see that 3 is duplicate, 45 is duplicate, again 45. I'm just printing it 2 times. And 3 is again duplicate just because of this. And 67 is also duplicate, right? Because 67 is coming 2 times. So for the moment it reaches 67, 2 times it will show that okay, yeah, 67 is duplicate. So if I ask you here, what is the time complexity for this guy? So the time complexity for this guy is again what? ON square, right? Because it will perform n number of times. So this will be, let's see, n number of times. This also for loop will be performed n number of times with all these if conditions. So it will be again n number of times plus some other constants. Let's see, 3 times if else condition or whatever the other constant will be executed, or let's see n number of times. So what exactly we are getting here? Let's see, we are getting around 2n, and here we are getting n. So if you calculate both the things together, so it will be like this: n multiply by 2n. So finally, what we are getting 2n square, and if I ignore n, sorry, if I ignore 2, finally we are getting what? N to the power 2. So for this logic, the time complexity will be O(n) square, the big O of n square, like this, big O of n square. Same thing if you're writing, let's see, a for loop like this, for loop, okay, and let's see, I'm just copy paste this. You're writing a for loop, and in this particular for loop, again you are writing one more for loop, right? Let's see, you're writing one more for loop. So how many for loops we have? We have 1, 2, and 3 for loops are available, like that. Okay, and let's say this is k equal to 0 and k plus plus, like this, and then you are doing something over here. So what is the time complexity for this guy? So it means the first guy will be executed, let's see, n times. This guy also will be executed n times, and this guy also will be executed n times. So n multiply by n multiply by n. What exactly you are getting? You are getting this n multiply by n multiply by n. You are getting what? N to the power 3, n cube. So the time complexity will be what? Big O of n cube. This will be the time complexity, right guys? So like this, we can simply do that. Bubble sort. Bubble sort is also a very good example of O(n) square. Yes, so bubble sort is O(n) square again, right? So if you see the graph, right, people might ask you that, okay, big O complexity chart or a graph over there. So if I draw a graph, now let's draw a proper graph over here. So this is my, let's see, y coordinate, and this is my x coordinate, right? Like this. Then what I'm going to do, this is my, okay, I would say that if this is represented by operations, or how much time it will take, or how many operations it will perform, and x is always elements. What are different elements that you have if you increase elements? So if I talk about O of 1, okay guys, O of 1 will be executed only once, right? Odd even number, m equal to 1, n equal to 2, simple variables, primitive and non-primitive types we have declared. So it will take only O of 1, right? Doesn't matter that, okay, you are using how much data you are using. So data is always same, the time will take same time. That doesn't matter. All exactly just like x and horizontal line, like this. So this is on what? This is, let's say I would say O of 1, a big O of 1. Okay. Almost like x-axis, almost like horizontal line. Then if I'm talking about that, okay, what is O of n? So O of n is slightly up, because obviously a for loop will be there. It will take more time. So this will be represented by O of n. So I would say that, well, this is O of n, big O of n. The moment you increase the numbers, okay, increase the numbers, the time will be like this. Okay, so if you draw, let's say for this, time will be like this over here, like this. If you increase this particular more numbers, the time will be slightly getting increased, like this. Okay, so operation, number of operation will be increased, or number of time will be increased slightly on the basis of the more elements that you have. If you are going towards x-axis, y-axis will be slightly up. So more elements and you can see the less margin of operations over there. Increment, okay, less time incremental in your operations. But let's talk about O(n) square now. O(n) square is really pathetic, really horrible. O(n) square will, okay, I'll just draw a graph like this. Yeah, that's a good option. O of square will be going like this. Assume that, okay, like this. This is O(n) square. I would say like this. Whatever, like guys, just don't go with that. So let's draw it again. So this will be O(n) square. Yeah, perfect. So the more the element that you have over here, let's say for this element, what you are getting, you are coming over here. This is the time it will take. We have less element, it will be like this. The more element you increase, now see this, you have, this is 0 element, this is 10 element, now this is the 100th element. For 100 elements, you assume that okay, where exactly it will match. So it will be like crazy, right? So this is O(n) square, I would say. O(n) square. Okay. And same thing with O(n) cube. O(n) cube is obviously very pathetic. So I would say O(n) cube will be like this. I would say more towards this, like this, right? For this single element, it will be like this over here. Okay, for single element, this, sorry, let me draw this again. Sorry for that. Like this. Now for single element, it will match somewhere over here. Let's see, or let's see somewhere over here like this. Whatever, I'm just tweaking the graph like that. Okay, so this will be O(n) cube. If you have 4 for loops O(n) n to the power 4, that will be more horrible, right? So these are the worst solutions that you're providing for your algorithm if you're reaching O(n) cube and O(n) square. That's why they say that, okay, right? Hey, can you please improve that? Instead of O(n) square, can you please achieve with O(n) or O log of n, right? Like that. So that's why, guys, these things are important. Some examples of, let's see, O of 1. What are the different examples? O of 1 is always, let's see, I want to fetch the data from array, right? I want to get the data from array. I want to insert the data inside, okay? Get the data, insert the data, or delete the data. So this will be what? This will be your O of 1, big O of 1, okay? Big O of 1. If you really want to get the data from a stack, so stack will be, okay, for stack, okay, no, right, not this O of 1, this will be O of n from array because you have to start a for loop. Same thing for stack also, it will be O of n like this. But inside the stack, if you want to insert the data, it will be O of 1, big O of 1. Same thing in array, if you really want to get the data, okay, it will be O of 1. For get, it will be O of 1. But if you really want to search the data, okay, in a particular array, in that case, you have to start a for loop. So whenever you're talking about a for loop, it will be O of n. If you want to delete the data, it will again O of n, because you have to start a for loop, you have to check the data is there or not, and then you have to delete. Okay, like this. Same thing with q also, like this. So these are the examples for this. If you talk about, let's see, quick sort. Okay, although we have not covered quick sort, so quick sort also will be O(n) square. Sorry, O(n) to the power 2, O(n) square, and O(n) square for bubble sort also. Okay, guys, you have to look into these search algorithms: bubble sort, insertion sort, and selection sort, and tree sort, and bucket sort. All these are guys having insertion also having O(n) square. Selection sort also is having O(n) square, like this. All these are the examples for O(n) square for search algorithms. Okay, because you have to write the 2 for loops in that case. We can improve with respect to merge sort. We can improve with respect to time sort, and like this. And then we can do a binary search also, that is O log of n. That we will do it in the next chapter. So I hope it's clear. I know it's a little complex, a little lengthy, guys, but it's simple. You have to remember the things. You have to find out the complexity, the formula, and everything you have to develop, and then exact same thing you have to showcase in the form of graphs and everything to give the right answer, to give the proper answer for whatever the algorithm or the logic that you have written. They might ask you any kind of question. right? And this formula will be applied for any programming language. You're giving the answer in JavaScript or Python or Ruby or Java or whatever, because the logic will remain same. The number of iteration to solve that particular problem will remain same. Instead of hash map in Python, you will be using, let's say, dictionary over there. A dictionary object you will be using over there, but it will always be O1 and lookup table. Okay, that will be O of 1. A simple even odd number in Python also will be O of 1. But same thing, if you really want to print a series or something like this, in that case, it will be ON in Python, in Ruby, in JavaScript, or in Java. It doesn't matter, right? The logic will remain same. And then how exactly you can solve the problem, and you can improve the code from ON square to ON or ON square to O log N, that we have to check in the next chapter. Okay, so that's all for this particular video, guys. I hope you are learning. Please practice, very, very important. I tried my best because this is a topic where it's difficult for me also to explain each and everything. But I tried my best so that there's some simple examples, some really good examples. You can give the same example at a time of interview also. Okay, and again, I'm repeating the same thing. Disclaimer is that okay, these are not the exact solution that okay. I'm not talking about the exact solution or the best solution. I'm just giving you an example with respect to time complexity. If you're solving the problem like this, what will be the time complexity with quadratic equation ON square or linear equation with respect to their respective graphs? Like that. And remember this graph, people will ask you, give me the graph of ON square or ON cube or ON and OF1. This will be the graph. O1 is the minimal time, ON square, and ON cube. Like that. Okay, so that's all for this particular video, guys. Thank you so much for watching this video. I hope you guys are learning data structure, and please subscribe to the channel if you are liking this series. Thank you so much.